Let's talk about my favorite thing to do in all of the sequences and series pieces, and that's the nth term test for divergence. The reason why is it's super lazy, and I love lazy things. What the nth term test for divergence says is that if I got a sequence and I want to take the infinite series by summing up the terms of the sequence, if that sequence don't go to zero, the partial sums are going to diverge. So the infinite series will diverge. And that makes intuitive sense, because if the sequence doesn't go to zero, let's say it converges to a number, well, you're just going to keep adding an infinite number of those terms. So it's going to add up to positive or negative infinity. But also, if it goes all over the place, there's no way to determine what it's going to add up to, because each new number you add, it's like a random number generator. You're just going to get random things out. And so there's no way to determine what your final sum is going to be, because you keep getting handed some strange value. So the point is that if the first thing you should always do, the first thing when you look at infinite series, is actually look at the sequence there and take the limit as n goes to infinity of that sequence. If that sequence doesn't go to zero, it will diverge every single time. So, for instance, let's take a look here. I got n over the natural log of n plus 1. Now, you might think, well, maybe that converges, maybe it doesn't, I don't know. Well, let's take a limit. If I take a limit here, if I take the limit as n goes to infinity, I get an infinity over infinity case. So I need to apply L'Hopital's rule. I take the derivative of the top and bottom, I apply the limit again. Well, that's 1 over n plus 1. So rewriting that fraction, it's just n plus 1. So the limit of this thing is positive infinity. Well, that's for sure going to diverge, because that tells me that this thing shoots way off to infinity. Like the sequence diverges. So if the sequence diverges, you better believe the series is going to diverge. There's no way that a sequence converges and the series diverges. Never happens. The second one's a little trickier though. I've got 3n squared plus 4 over 2 minus n squared. Well, if I take the limit here, I also have like an infinity over negative infinity. So let's apply L'Hopital's rule again. I get 6n over negative 2n. I can reduce that fraction to negative 3. So I get a sequence that converges. So the sequence actually converges to negative 3. But the problem with that is that, let's suppose that the sequence did converge to negative 3. So after, let's just say 100 million terms, every term is basically negative 3, because that's the idea of what convergence means, is that each term, if it's converging to it, it means it's becoming infinitesimally close. So every term is basically negative 3. Well, if I take negative 3 and then just continue to add negative 3's from 100 million terms to 100 billion to 100 trillion to so on and so on, I'm going to keep adding negative 3's and just shoot down to negative infinity. So it's going to diverge every time. So if this isn't zero, if it's not zero, then it automatically diverges. Now, I'm about to get angry. I'm about to get angry at you for no reason, because you've not done this, because you're learning this. But every time, pet peeve, they'll say, well, I'm going to take the limit, and if the sequence converges, well, the series converges. No, false. That is so incorrect. The nth term test does not tell you if the series converges. You do this on a test, you lose mad points. This is pet peeve, not just mine. It's a lot of people's pet peeve. So, for instance, this is what's called the harmonic series. There's a lot of really cool things about the harmonic series and how you can add up to that. And it turns out that it diverges. But if it diverges, but wait, the limit of that sequence is 0. That don't matter. That's not the point. What this says is if the limit's 0, if the limit is non-zero, it diverges. It didn't say if the limit is 0, it converges. It definitely didn't say that the convergence or divergence is related, is determined only by that limit. It says if it's not 0, it diverges. It doesn't say more than that. It doesn't say anything else. I'm getting angry because I'm going to say this, and I'm going to do all this, and then somebody, some yokel who watches this video is still going to do this, and they're going to lose bad points on the test. And then they're going to come back to this video, and they're going to hear me rant, and they're going to know that I'm right. I've been right all along. I just want to impart this to you. Beat it into your head. The nth term test does not tell you if a series converges, but it's really neat to tell you whether it diverges.